And we will now continue with the next speaker. Please welcome Marcel Rümenapf, Head of Sales for the German-speaking market at Siemens eMobility, and soon to take on all of Europe. Siemens has been closely involved in shaping megawatt charging, for instance, and the standards that will define the future of heavy-duty transport. Today, he brings us a case study from the Netherlands, showing how a smart energy management can unlock fleet electrification and make the shift to zero-emission logistics not just possible, but also practical. Good morning, Marcel.
Good morning.
So, Marcel, how many electric trucks have you already seen today?
Unfortunately, zero, but there's a good reason for that. And I will come to that in just a minute when I go to my slides.
Okay, so you will tell us why you have seen no electric trucks today. Marcel Rümenapf, electrifying logistics, the path to reliable, profitable, and scalable truck charging. The digital stage is all yours.
Thank you very much. And good morning, everyone. I'm actually today in Katowice, Poland, where I've been attending the annual New Mobility Congress yesterday. And that's also where I saw several electric trucks on display. Unfortunately, I've not seen any here in the streets. And there is, let's say, that is reflecting the current situation that we see in the market, I think, very well. Now, throughout the next few minutes, next 15 to 20 minutes, I would like to structure my presentation very briefly in a brief outlook on the market that's already on display here, then provide a couple of examples of what's going on. Again, touch on the TCO as Tony already did, but more with the focus on the charging itself. Then take a different perspective, once from a CPO view, the other time from a depot operator view on the whole topic of charging. Elaborate on the importance of service, of charger operation and maintenance, load and energy management, again with some examples from the field, including the Dutch case that Carla just mentioned. And in the end, finishing with a very brief outlook on the topics to come, at least the kind of discussions that I'm expecting to coming up in the next few years. With this, let me dive right into the topic with the market status on the market. Siemens, for example, we have a goal for net zero in our entire supply chain until 2050. And we are already starting with first projects, first pilots, for example, out of our charger factory in Portugal. We are organizing first transports to our customers via electric trucks. And as we are doing, also other companies are doing, and that's the reason why at the moment we see approximately 6,000 electric medium and heavy duty trucks on the streets in Europe. That figure varies a little bit depending on which source you tap into. It could be 10,000 more or less. But the message is it's a drop in the ocean because we are comparing at the total number of trucks on European streets being 6 million. So there is still a very long way to go, and we will have combustion engine trucks in the streets for a very long time to come. But we're on a good way. New registrations. We are currently looking at a share in new registrations of 3.6% e-trucks in 2025. And that share has actually increased from, I believe, 2.3% last year, 2024. So it's coming and we're getting there slowly but steady. And there are some companies leading the race, and that's something we will see on the next slide. One of our partners at Siemens is the company Nano Jansen. If we could move to the next slide, please. Thank you very much. Nano Jansen, especially some of you from the German-speaking community might be aware about the electro trucker Tobias Wagner. He has been driving for Nano Jansen, and they have just recently opened up one of their depots very well equipped for electric trucks. They have installed 10 Siemens C-Charge-D chargers, 300 kilowatt each, for a fleet of, I think at that point, 20 trucks and several more to come. What's interesting, they have also included battery storage, photovoltaic, and even a wind turbine, which make it an extremely interesting microgrid case in this regard, and really, let's say, pushes the topic for electric mobility and green energy to the next level. That's, let's say, the important part when you take these kinds of decisions, when you want to come up with these kinds of projects. You want to take a very close look at your cost. We already talked about it, especially in the logistics business. Margins are extremely slim, and whatever we do must make sense from an economical point of view as well. So if we would move to the next slide, please. It's the question that you will be facing going forward, where you want to charge. Do you want to charge in the public space, or do you want to install chargers yourself and operate them yourself, and then run your trucks on your own chargers? In the past, that question did not really come up because there was hardly any charging possibilities in the public. But as Tony already mentioned, there are many projects coming up. We have the AFIR program from the European Union, and the whole topic with public charging is really being pushed. And also the prices that we have heard are becoming more and more attractive. So in the future, you will actually have a choice. Should you install yourself, or do you just want to rely on public charging? But if you install for yourself, that could make a lot of sense from an operational point of view and also from a cost point of view. You should definitely consider what kind of charging setup and infrastructure layout you want to go for, as space is expensive. No, would you please stay on the previous slide? Thank you. As space is expensive, you want to make sure that the utilization of the chargers is high. You want to make sure that the uptime is high, so you need to assure proper operation and servicing. And of course, you want to make sure that the electricity that you procure comes at a low cost. There are all levers for these different needs that you can pull to make sure that you're on the most efficient way forward. And that's the point now. Coming to the next slide, please. When we take two different perspectives, one is for the on-route charging case, being a CPO, establishing chargers in the public domain, or on the right-hand side, being the private operator in a depot or on on-premise. Now, when we think about the CPO, the public charging, we always think about this very need for high power charging. This is where the idea of megawatt charging was initially born. We're now all pushing for the NCS standard and the projects that will be coming up. But what should be considered if we drive along the highways at nighttime, what do we see? We see all these trucks parked overnight, where the drivers are sleeping and waiting for their break until the next morning comes, they can continue their drive. And these are all opportunities to charge. So we also need to consider the flexibility for overnight charging also in the public space. On the other hand, on the right-hand side in the depot, it's not only the overnight charging case that we usually anticipate with depot charging, but it's also the top-up charging, the need for potentially higher power ratings during the day, in case some of my vehicles come back during the day for a quick break, or I need to top up because I had some kind of disturbance en route before, and I need to be able to cater that problem. In any case, space is expensive. I want to be as space conscious, as space efficient as possible, having low footprint of my charging equipment. And what has proven to be a very good solution in the bus market, we're now also providing to the truck market these kinds of gantry solutions where you actually have the charging coming from the top, which will work very well for low power charging, where the cables are not as thick and you do not need liquid cooling. But that's a topic very specific topic. So once the chargers are installed, you want to make sure that they're up and running. And that brings me to the next slide, please. It's about service. So when we talk about, or when we think about service, and that's absolutely independent if I'm a CPO or if I'm a depot operator, I want to be able, first of all, to do as much as possible remotely, because that will be quick and that will be cost efficient. So I want to remotely detect any kind of failures. I want to remotely diagnose these errors and hopefully remotely resolve the problem. If that's not possible, I want to make sure that I have fast response times of the people coming to site to fix it, and then also fast resolution times for the fixing itself. In that regard, it might make sense to also think about storing spare parts on site. Now, to enable fast and quick reaction times, it might make sense that I qualify my own personnel so that they can already jump in and do a quick fix. So I want to have the possibility to train and certify my stuff for the charging equipment that's installed with the charging OEM. And most likely, I also would like to have access to the service backend, or at least to parts of that service backend that I can already pull error messages, maybe try a remote reset myself, or push for firmware updates on my own. That will all help to improve the service experience. Last but not least, a topic that is easily forgotten or overseen is the topic of interoperability. We have pretty complex systems that we are throwing together. We have the truck, we have the charging, we have backend systems. All these components need to properly communicate and need to interoperate. Now, if there is a firmware update in one of these components, sometimes it comes to a hiccup, and that needs to be solved. So also here you need to make sure that there's a proper expertise in the background to quickly solve these issues and to get things up and running quickly again. Now, if all this is assured, then we would move to the next slide and we would take a look at the operation of a depot itself. So operating the depot, I want to make sure that I'm monitoring my chargers, that I pull reporting out of them. So what's the charger status? What is the usage? How much energy have they supplied so far? That kind of information will help me to plan my maintenance, come up with some kind of predictive maintenance scheme. And if I'm able to also allocate the charger usage and the energy that has been transferred to certain vehicles or even companies, I might enable third parties to also charge on my premise. I can do billing and I can charge them to pay me for the electricity they have consumed. Another big topic is the preconditioning, especially for the battery preheating in wintertime, but also for the driver comfort. Also a topic that comes from the bus operation, but will be as important for the trucks as well. Smart scheduling is a topic where you put in your drive schedule. When should the vehicle leave in the morning? When is it expected to come back at night? And then the system can come up with the best possible charging schedule, considering all the vehicles that need to be full at a certain time, and shifting then the load to prevent power peaks at your grid connection, and potentially to use time windows during the day when it's especially cheap. And if you want to take that even one step further, we are developing day ahead market connection that's already in place in the Netherlands and in Belgium, for example, where you can participate in the day ahead market and design or plan your charging scheme accordingly, sometimes even enabling negative market pricing. This is, let's say, on the depot management. If we now would move to the load and energy management on the next slide, it's the differentiation between load management and energy management. One system is really focusing on the consumption side. I am installing chargers. These chargers need to be powered up. I need to have the energy available for them. But I will also have other installations at my site. I will have a building. At least it needs to have lighting, but I might also have other process needs that might take up energy. There could be a refrigerated warehouse. There could be, I don't know, a cement factory that I'm actually running that consumes a lot of energy. And to orchestrate all these consumers, I want to establish proper load management to make sure that my grid connection is not being exceeded. On the other hand, if I'm thinking about optimizing my grid connection and maybe bringing in battery storage that can provide as well energy, or to bring in photovoltaic, or as Nano Jansen did, wind energy, wind turbines, then I want to look at a proper energy management system to orchestrate all these different suppliers and then line them up with the different consumers on site. But that's a topic I think the next speaker, Jan Niklas, will also touch up on and go more into detail. But what does it now mean in real life? And that's the example that I have brought with me from the Netherlands. We are working together with a customer in the greater Amsterdam area called Sligo. Sligo is the largest Dutch food service chain, and they're delivering food and beverages to hotels, to restaurants, and to bars. They have more than 1,000 customers around the greater Amsterdam area, and they're running a fleet of fully electric trucks. And that puts them at a certain challenge, especially because of the grid connection that's available. And I've shown that, visualize that on the next slide, that you get a rough idea of what we're looking at. On the very left-hand side, that simulates or that symbolizes the fleet of 70 electric trucks they have in their operation. These 70 trucks are charged by 36 charge points, and these 36 charge points are again powered by 12 chargers. The 12 chargers have 180 kilowatt peak power each, so that adds up to 2.2 megawatt total potential peak power. On the other hand, because they do handle food, they have a warehouse that is chilled, that is refrigerated, and that consumes in peak seasons as well 1 megawatt. So the peak demand adds up to a total of 3.2 megawatt. On the other hand, on the supply side, they have a grid connection roughly to maybe 2.2 megawatt, and they have added also photovoltaic with 300 kilowatts. So when the sun is out, they come up at an optimum of 2.5 megawatt. Now, to make sure that my load on the left-hand side never exceeds my supply on the right-hand side, I need to have a proper energy management system in the middle. And this is what we have provided. This is how they run the operation to make sure that the 70 trucks are always up and running and ready to go with enough energy in their batteries. And it's working very successfully for quite some time now. Another example that I have brought with me comes from Austria. In Austria, we're working together with OMV, big gas station chain, are now also going for electrification. And they are preparing for truck stops, establishing a network of truck chargers along the Austrian highways at the moment with 400 kilowatt DC chargers provided by Siemens that are especially catered for the truck charging use case because the power rating, the power curve enables long charges at maximum power and does not go into derating. A problem that you see today with some of the charging is that they're more designed for smaller passenger car batteries where the charging at high power does not take for such long time, and then they go into derating because power electronics get hot. So that's not the case here. You can really charge the big truck batteries at full power throughout the entire charging circle without any limitations. So that is helping. And of course, we are also preparing for the MCS standard coming up for the megawatt charging need along the highways to provide solutions accordingly. And whoever is at the Bus World in Brussels next month is highly welcome to visit us at our booth, as we will actually have a market introduction of the next big thing to come. And that brings me already to my last slide, a little bit of an outlook on future trends, or at least the kinds of discussion I'm expecting in the future to come. I do not think that after the megawatt charging, the MCS, that we will still be talking about power ratings, about further increasing the power, or certainly not as extensively as we're doing that now. But I think it will be other topics that we will be talking about. One of them is cybersecurity, as charging infrastructure is or will become critical infrastructure. We need to make sure that it is safe to operate and that it does not get manipulated in the background by others and compromised. And therefore, we really need to push the topic of cybersecurity. Sometimes I find it a little bit frightening how optimistic we are in this regard, and how we have not yet embraced that risk and need to make sure that we properly cover that risk. Also, our experts are not getting tired of promoting the topic, because it's already in EU legislation that there's a lot that needs to be done. The other topic is flexibility. At the moment, the standard is CCS. The MCS standard for the trucks is coming. So you want to have a system most likely that you can adapt in the future, maybe from the CCS to the MCS, or you can add power ratings so that you're future-proof. And the other big thing will be artificial intelligence. So with artificial intelligence becoming more and more important on the service side, also on the operation side, what we will be trying to do is to better predict the future, to be then also better on service and better in operation in terms of reaction times, in terms of pricing and cost cutting. And with this, I am actually at the very last slide. So I would like to close my session. And once again, please keep in mind when you think about chargers, think about beyond the hardware. There is more, and we're there to help. And a little bit already looking at my next speaker, Jan Niklas from ENGIE. I would be very interested when we talk about all these topics. We should consider all the green energy, all the CO2 balance, and what the situation actually is in Germany with this nuclear power we are importing from France, if it's really the case, or what's the situation there. Maybe that's something you want to touch on. Thank you very much.
Thank you so much, Marcel. Are you trying to steal my intro for Jan Niklas, for the next speaker?
Sorry, that was just, I took the opportunity.
That's all right, no worries. I do have a few questions for you before I let you go. You said think beyond hardware, so let's think beyond hardware. You showed that diagram as to how much power actually is needed to charge that fleet and to power the refrigerated warehouse. So there are enormous energy flows. What role does an early collaboration with grid operators play, and how can operators maybe best prepare in that sense?
It's very, very important, especially of the times that you need to get these kind of projects approved. We have very long times that we are looking at, and the government, also the European Union, has realized this, and they're pushing for measures to accelerate. That will really help. And that's, of course, a topic in my very own depot project, but that's also a huge topic when we look at all these electrification plans and programs in the public space. For example, with the AFIR program that is to come. In Germany, for example, there is the German truck tender that's currently in preparation or ongoing, where the authorities have already realized that problem, and they have send in the applications in advance, that the CPOs do not need to worry about it, but that we are time efficient in this regard.
Okay, so working together is always best. Still, I have a question that's maybe more of a personal answer from your perspective. What milestone must be achieved in Europe by 2030 to make electric heavy-duty transport mainstream?
I think we are on a very, very good way. I think so we have all the programs in place, all the topics that are coming up. What I see is definitely not helping the discussion if there is uncertainty. So all the players need to have certainty. There needs to be planning security. And if I start all of a sudden a discussion, if the combustion engine might be prolonged, if you can that does not help, right? So decisions will be pushed to the future until I can really predict what's going on. So this is something where we should be extremely careful. What kind of messages do we bring out to the public? And what are we really pushing for, and what is our aim? Because as Tony already mentioned, I mean, we are behind Paris and we have a problem with our climate. And this is why we're doing all this, what we're doing. But sometimes that is simply forgotten.
All right. Marcel, thank you so much. That is something we'll definitely talk about a little later in the discussion round again as well. Pick a technology that works and stick with it, and just move that along. So thank you so much, Marcel, and I'll see you later in the discussion round.
Thank you. My pleasure.